Okay, we're back. Part 3. We're starting around number 19 under La Nina on 25.1 notes. So we have come to recognize, researchers have, I'm not a researcher formally, but I play one on TV, that when the surface temperatures in the eastern Pacific are colder than average, so that's over by off the coast of California, off the coast of South America, then we have a La Nina. And a La Nina gets triggered, and it has certain weather patterns. So what are those weather patterns? What are those weather patterns? Droughts in parts of South and Southwest from Arizona to Arkansas and Louisiana. So we can get droughts in the southern part of the United States. Less rain than normal. Droughts in South and Southwest from Arizona to Arkansas and Louisiana. I know, it's not really Arkansas, it's Arkansas. That's fun to say, Arkansas. Can you say Arkansas? I know you could. All right. And then above normal temperatures, or above normal precipitation in the northwest and the Tennessee Valley area. I know that's cut off down here, but it says above normal precipitation in the northwest and the Tennessee Valley area. Okay, let's talk about what a monsoon is. There is a misconception that a monsoon means rain. A monsoon does not mean rain. A monsoon means a reversal of the wind. So you're probably smarter than most college students. They think monsoon means rain. One of the results of a monsoon is increased rainfall, but it doesn't mean increased rainfall. It means the winds switch direction. The winds switch direction. Okay, so monsoons are seasonal reversals of winds in the direction associated with large continents, especially Asia, and that also affects what we call the Indian subcontinent. So that's what a monsoon is. It affects the Indian subcontinent. So we know that in the summer, hot stuff should be going up, cool stuff should be coming down and taking its place. So in the summertime, if winds are blowing onshore, they're bringing moisture with them. Well, what about these things called the Himalayas? The Himalayas are there, and they're going to cause that air to ramp up. And as it ramps up, it cools, and as it cools, clouds form, and it rains a ton on the Indian subcontinent below the Himalayas because of that, as we know, that's orographic effect or orographic lifting. Orographic lifting. That's when the mountain ramps the moisture up and causes clouds to form. The drops get too heavy, and then they rain, and then they flood, and the people get displaced, and nobody's happy. So in the summer, the winds blow from the sea to the land, and that is a wet condition. And then in the winter, the winds blow from land to sea. So that's actually a dry condition. So what it says on the notes here is correct, not what, or on the PowerPoint, not what it says in your notes. So in the summer, that's when it's wet. So change that. Summer is wet, and in the winter, the wind blows from land to sea. So it's blowing the moisture away from the land, so it's dry. So that's what a monsoon is. It's just a breeze that, or a wind that blows the moisture onto the land. So when the winds shift, then it causes lots of rain. Let's see where I am, 4:31. Okay, I want to keep these at about 10 minutes. Okay, so here are some pictures of monsoons. We can get big flash floods in the southwest. If you've been in Arizona in the summertime, where my folks live, you can actually get some really nice cooling rains, but also some flash floods. You can actually get flooded streets because it just keeps raining and raining and raining because those winds are bringing the moisture onshore. Okay, let's talk about the third one. Topography. Remember, topography is just surface features. Topography means surface features. Surface features of the land or the water. So we know that mountains can play an important role because they can ramp the air up and it cools. And as we know, they can affect the amount of precipitation because we did a whole week-long lab on looking at data. So elevation just means your height above sea level. You might remember that from first semester, your height above sea level. And temperatures usually decrease or go down or get colder as the elevation increases. For those of you that care, it's about 2 degrees Fahrenheit per every 1,000 feet. That's what we call the natural adiabatic lapse rate, if you care. And I know you do. There's something called the rain shadow effect. So we've already talked about the monsoons bringing cool, wet air in. They hit the mountains. It gets ramped up. As it goes up, it cools. And then clouds form. Drops all the precipitation on what we call the windward side. So the windy side, or the windward side of the mountain, gets all the precip. And then by the time it goes over to the other side and drops down a little bit, not only do the spaces squeeze out, but it's lost a lot of its moisture. So we call that the lee side, or the leeward side of the mountain. And over here, you have what's called a rain shadow. You have a rain shadow. So let's put a personal connection to this. If this is the Sierras, and Sonora is somewhere along that western slope, that would make all of this Eastern California, or as Arnold says it, California, and Nevada. So Eastern California and Nevada are dry because they are in a rain shadow. They're in a rain shadow. We are at almost 8. So humid air on the windward side of the mountain moves up the slopes, it cools, condenses, and forms clouds and rain. Remember, you need a little particulate for clouds to form, in case you didn't get that. Goes up the windward side. By the time the air reaches the leeward side of the mountain, most of the moisture is lost. It's not that it can't rain over here. It does a little bit, but it loses most of the moisture. Come on. So once it gets to the leeward side, it drops the moisture. So there's another view of it. This would be the rain shadow. This would be Eastern California, Nevada. This would be the western slope of the Sierras, and San Francisco would be over here. So we call that a rain shadow because it's dry on the leeward side. Rain shadow, woo! There's another picture of it. Moist air falls over here, dry over here. And so we can actually see that the rain amounts go up as you move west. You hit the Sierra Crest, and then it becomes dry again. So you can see exactly where the Sierra Crest is. It's right along this eastern edge, and then it becomes brown again. The dry area on the leeward side is called the rain shadow. All right. We're at about 10. We're at the end of part 3. We will continue again in just a sec.